So in part 3, we're going to talk about the components of a Wi-Fi network. We're going to start with devices and access points, and we're going to talk about the other components in the next part. But as you know, components of the Wi-Fi network are devices, access points, their antennas and power supplies, switches, controllers, application servers, routers and internet connection, or the wide area network, and wiring that connects it all together. So user device could be anything: a computer, a printer, a tablet, a cell phone, a label maker, a voice over IP phone. With the Internet of Things, there are many other devices like ultrasound machines and vehicles that could be on the Wi-Fi. So a common scenario is that the client is upgrading or installing a Wi-Fi network because they want to support new devices that are being deployed. So example, client switching to inventory management system, and as a result they're buying barcode readers for their warehouse and wireless printers. So if you're responsible for supplying user devices, you need to think about how each device is connecting to the Wi-Fi and its battery life, how much time you need to obtain the quantity. As I said earlier, if you're buying 1,000 phones or 5,000 phones, enterprise-wide, the manufacturer may need a month or 3 months or 5 months to get you the stock. And what kind of training are you providing the users, and how are you going to support these devices a year or 5 years from now? And then access points. So there's many different access points and brands and manufacturers, and how you choose which one is right for you. And here we have Cisco access point, but you don't necessarily need a Cisco access point. Does the client use an access point brand already? If you're adding to the Wi-Fi, you're probably going to be using the same types or manufacturers that are already in place. And then you need to ask yourself if you want to buy the cloud managed access points, which I don't want to say that they're plug and play, but they kind of are. You plug them in and they connect to the internet, and then you go online and you manage them from a central location. Even if you get 20 buildings or 1,000 buildings and 10,000 access points, you can go online on the device manager and just manage each one. And so for Meraki, it kind of looks like this. You can log in and see everything, basically. So with the cloud, you've got many advantages. There's many manufacturers that are selling cloud access points, and they're plug and play, not quite, but you don't need a controller, and we'll talk about controllers later. But for the most part, like Cisco Merakis, for example, can work together. So if you got a number of Cisco Merakis in your network, they can communicate with each other, and they can adjust their signals, and so that because access points can interfere with each other. So instead of having to adjust them manually, they talk to each other, each one, in real time based on how the situation changes, and they give you a better Wi-Fi experience for your users. Now, of course, the disadvantage is that you can't necessarily control them as well as you want. Depends what features are in the Wi-Fi manager. In the cloud, the manufacturer may still be working on the software even after you've purchased the APs. The manufacturer probably will charge you a license fee. You can save up front if you buy it in advance for like 10 years or whatever, but yeah, you bought this device and you have to pay a license fee to keep using it. And of course your access points have to be able to connect to the internet, or you can't use a web-based manager. Maybe you don't want to do that. And if you don't use a cloud, then you probably need a controller which manages the APs. And if you don't have a controller, then you're gonna have to log into each AP one by one and manually configure it, which can be a bit of a bother if you've got hundreds or thousands of APs, even a hassle if you have 5 or 6 APs. So, and of course, a controller can manage any number of APs you want it to, but you have to have a license that you buy at one time. So you might buy a controller and it can only manage 5 APs, and you got 10, then you have to buy a license to manage 5 more and stick it on your controller, and that costs money. Now, the 2 things you need to know about an AP. Number 1, every AP has to get data from somewhere, and it has to get electricity from somewhere. If it doesn't have data and it's not talking to the rest of your network, then it's not working. If it doesn't have power, then it doesn't turn on, so it's not working. So you have to think about how it's going to get data and power. And as far as data goes, it's obviously getting plugged into a network switch, and that means you need to have an Ethernet cable from the AP to the switch, and the network cable has to be 300 feet or less. That's the standard. If you run the cable more than 300 feet, then maybe you won't get as good of a signal, if at all. And there's an exception, which we'll talk about. So, how do you get data from a switch to an access point? Well, you need an Ethernet cable, like I said. Preferably you've punched this data cable down to a patch panel and then patched it in. There are APs that have what we call SFP, so you can actually run the AP on a fiber optic cable instead of a Ethernet cable. Then you don't have the 300-foot restriction, but these aren't very common APs yet, and of course you need to run a fiber optic cable, and you need a switch with an SFP port so you can plug the fiber into the switch. And you have to think about power, because fiber optic cables don't carry power. So how do you run a cable to the AP? We're not really going to talk about that, but obviously if you can move or use an existing cable, that will save you time and money. If not, then maybe there's a conduit that goes from your IDF to the location of the AP, or part of the way there, or there's a raceway if you're running cable above a dropped ceiling. Maybe it's open air, so you can use some J hooks or zip tie the cable to the joists or something else. Obviously, Cat5e is the most common type of cable, and the Cat6 is pretty common. More and more people are using it, and now Bloodin and whoever else, they're pushing Cat6a. Some people are using it, but I maybe don't think you need it for an AP yet. And again, you can use fiber, but then you need a compatible access point, and of course fiber doesn't support power over Ethernet, which we'll talk about. So as I said earlier, you should be familiar with BixZee, and use the J hooks and make sure your cable bend radius is okay. Put some service loops in case you need to move the AP. Don't run the cable next to a power line. Use armored cable. Your client may have additional standards that they expect you to follow, maybe even more stringent than the BICSI standard. That you have to keep that in mind. And then, of course, you should consider the fire code or the building code for your area, and use cable that's plenum rated when you're running it in a plenum space. So plenum space is anywhere where there's a building supply air. So a drywall ceiling, if it's above the drywall ceiling, you probably need plenum cable, and make sure your cable is UL listed. If you've drilled through a firewall, basically a wall that takes longer to burn, then you should use fire stop. It's like a putty and it allows you to seal that hole back up. Same thing if you're installing a conduit through a firewall, make sure to seal around the edges of the conduit. So if you look at the back of the Cisco AP on the bottom, you see two ports. The first one is the Ethernet port, and the second one is the console port. So the Ethernet is where it plugs into the switch, and the console port is where you plug a console cable in order to configure it. And the reason this is important is when you're running cable, make sure to plug it into the Ethernet port. Otherwise it won't work. But the second consideration, this is a very good tip, is run two data lines to each access point. One goes to the console port and one to the Ethernet port, and patch them both into the patch panel. And the reason you would do that is so if you need to manually configure an access point, you can just plug a console cable into the patch panel on the floor and configure away. Why are you gonna do this? Well, if you look here, you look at this warehouse, you've got an access point way up in the ceiling, and you need to change the settings on it for some reason. And it means you have to get a scissor lift, you have to climb up all the way up there with your laptop and plug it in. Ain't gonna happen. So now you can just do it from the ground. Of course, there's no console over fiber, so don't even think about that. But for the most part, this has been pretty handy in many cases. So think about, also running more data lines than you need, especially in areas where you have lots of APs, and maybe in the future you need to increase the density of the AP coverage, or you can use the data for other devices like signs or cameras or whatever. Running a second cable with the first one, you're basically just paying for the cable. Labor cost is pretty minimal. So we've also got APs that can go outdoors, and here's an example of an access point with some antennas mounted out in the parking lot. So when you install an access point outdoors, then think about the weather and the temperature, and use cable that's waterproof. They've got gel-filled cable that can survive -40, or a waterproof conduit, or put everything in a NEMA rated enclosure so you don't have any problems later.